Now talking about renewable energy, you see, it is seen that world over the scenario is different. Some countries in renewable energy, the emphasis will be on available resources, because what is available in Delhi might not be available in London or in New York. So number one is the resources, which renewable resources are available. Though this seminar is dedicated to solar, I'll just like to solar power, which is particularly relevant for India, we are solar abundant, but in many of the countries in the world are not so blessed as us. So they don't have solar and they have other energies. That is why we talk about different energies. So first of all, what is the ratio? Like which country is utilizing how much renewable, like total power consumption of their total power consumption. So I was able to find on the net that Norway is a country which is using 98.5% of its total energy, which it is using from renewable sources. Similarly, Brazil, 89%. Now, these might be like Norway might be a small country. So the in gigawatt, the consumption, the installed renewable capacity may not be too much, may not be high, but it is very good that 98% of energy is coming from renewable sources. Meaning we can say that in this particular country, there is the power generation, electrical power requirement is totally being met. Because electrical engineering is my subject, so I'm talking from that point of view, that they are not for generation of electricity, they are almost not generating any emissions, or they are not polluting the environment at all, because 98%, 98.5% is coming from renewable sources. So similarly for different countries, and going down, Brazil, New Zealand, Colombia, Canada. So this is the rank. Then Germany has 44% of its energy coming from renewable sources. In India also, almost 40%, I think we have reached in our national power grid, almost 40% of the electrical installed capacity, you see, because at any particular instant, how much is being renewable energy is being generated is another matter. Like if it is evening or it is night, so solar will not be generating at that time. But 40% of India's installed capacity is renewable. So we can say that about 40% of carbon neutrality we have achieved, because at least you can say that we have reduced the emission by at least 40%. Now coming to the other data, China is world's largest producer of solar energy with about 710 gigawatts of solar capacity, installed capacity they have, and their growth rate is also very high, which is 42%. 42% is their annual growth rate at which their solar power capacity is increasing. And similarly, now talking about, because I'm going to present a case study also, unfortunately, because of lack of proper information with me, I could not prepare, though the data is there with me on my laptop, I could not prepare a presentation. Maybe next time, if I have a proper information, I'll be able to do it. But I still thank the Institution of Engineers for giving me an opportunity. So, because the case study is related to the rooftop solar power plant, which is installed at I am a professor of electrical engineering in Madhav Institute of Technology and Science, deemed university, Madhya Pradesh. And we have a 100 kilowatt peak solar rooftop plant. And I'm going to present some brief case study about that plant, how that plant is helping the society and the solar sector. So therefore, I'll give you just a little overview about the solar rooftop sector, particularly the rooftop sector. So again, China tops in the rooftop sector with 225 gigawatts, and maybe more now, because this data is collected at the end of 2023, and now we are almost at the end of 24, so slightly more. Germany and US follow with 55 and 47 gigawatt respectively. So you see 225 gigawatt China, whereas Germany 51 and US 47. And India is only 11.6 gigawatt at present. But we are, very fast. We are increasing the capacity. And there are certain challenges in the rooftop sector. But I think that rooftop solar is a very good answer to saving money, not only saving money by the consumers, even household consumers and other the commercial consumers. So I am always an advocate of rooftop solar. And though you have to like sacrifice or maybe give a portion of your roof for this particular purpose, but the payback period comes out very good. And presently with the solar, because electronics is progressing very fast and the solar cell prices are dropping tremendously, continuously they are dropping. So definitely this particular sector helps a lot. Now again, little bit of which type of other solar energies we are using. So which type of other renewable powers are being used for constructing the hybrid renewable sector, hybrid renewable power generation. Why do I say hybrid? Because most of the power in the world is still coming from thermal power stations, large super thermal power stations, where the power is generated at remote locations and then transmitted over long distances to the consumer end, because the locations are near the coal mines and all that. But we all know the future is not very good for that sector, though they are there and the infrastructure is there. Therefore, till they can continue, they will be a major part of our, like right now also, almost 60% of India's power is coming from, maybe a slightly more than 60 also, is coming from this thermal power sector, coal and all. And at other times also, like when there is no sun, like in the night and all, so that time also the thermal power stations are always there. They work like a storage system for solar power actually, because when solar is not there, then these systems are helping us. So other than solar, there is wind, there is wind power. In wind power also, India has got a very good position. India ranks at 4th in the world in wind power. And in India, Kanyakumari, near that coast, there is a Mupandal place, Mupandal power station, which is the very large wind power plant, 1500 megawatt. And India is at the 4th position. Of course, China is at the top and Germany is, I think, 2nd or 3rd, but India is at the 4th position in wind capacity. So when we talk about wind capacity, so after, yes, Germany and all these, yes, after that, similarly, like when we are talking about power, so even a small, maybe a very small amount of power generated using biogas or biomass, but in today's time, that is very relevant when we are constructing or talking about hybrid system, like in our MITS campus also, we have the power grid, which is mostly, as I said, about 60% thermal and 40% renewable, but renewable not always available. And in addition, we have a 100 kilowatt plant. Other than that, there can be, like, we have large number of forest cover, large number of biomass is there. So if we make a biomass plant, maybe small amount of power will be generated. But as we know that even a small, even if a drop of, water can fill slowly, if you just collect drops of water, ultimately they make seas and they make big seas finally. So everything in energy is important. And therefore, and another thing is that waste also can be converted to power. In order to achieve carbon neutrality, we cannot leave and we should not leave a single stone unturned. Now talking about this, as I said, the hybrid system will be, there will be solar, there will be wind. Now in a location like Gwalior, we don't have wind power plants, because for wind power plant, the minimum average wind velocity required for a place is about 3 meters per second. And in Gwalior, we have average velocity is less than that. Sometimes the velocity is high, but average velocity is less. So places like Gwalior are not considered to be good places for installing, like good locations for wind power plants. So we don't have it. So generally Gujarat and coastal areas and all, they are very wind rich areas. So first of all, when we are making a hybrid power station, hybrid power plant along with the grid and other resources, so number one will be the availability of the resources. What is available, only that we can use. Then the most important thing will be what size and what capacity power plant, what capacity of solar should be there. So naturally there will be constraint. Like if we talk about MIT as Gwalior, my institution, my deemed university, so then of course there are site constraints, that how much of the roof area or how much of the land area we can, use for the for making the constructing the solar plant. Solar has another very big advantage, that it can be like, it doesn't take any installation period. It is very fast, it is installed. Dr. Malvi, who is here and who is perhaps going to talk after me, will be telling you just completely from a different aspect about, he is also an expert in solar energy. So he'll be giving, I'm talking from the electrical power system point of view, electrical power generation, because we cannot, survive without power for even a short time nowadays. We immediately require backup, etc. So coming to backup, in all these hybrids, the most challenging thing is in renewables that their availability is always fluctuating. The moment there are clouds or something, the solar power will not work. If there is no wind, the wind station will not generate any electricity. So the main, we can also call it a limitation with these, because earlier cost was a limitation. Now the solar power is very competitive. Solar power is not expensive now. The rates have gone down, but the variability is still a big constraint. So the moment, if we want to give a stable power system, stable power, then we require storage. So storage of electricity is becoming a very big area of research. Storage means battery storage, different type of battery storage, different type of fuel cells are being used, different batteries, there used to be, there was a time only lead acid batteries were known. Now there are many other kinds of batteries and different storage, even concentrated solar power storage, heat storage, and many other kinds of storages are used. Because of this reason, storage will complement the renewable plant. When the renewable is in excess, renewable power is in excess of the demand, it will be stored. And when vice versa, then the storage will make up or will supply power and meet the load in this way. Now, whenever we are designing such kind of system, so first thing, as I said, will be availability of what are the materials and all that, what is the space. Depending on that only you can, and there are many government policies also, government gives subsidies also. So all this is there. But main thing is the life cycle cost is the most important decision-making factor, that what will be the cost of the plant to us for, let us say, for a period of 20 years, particularly for solar, it is 20 years, the life cycle. And the comparison, if suppose I make a design and someone else also gives a solar power design, solar power station design, then the comparison will be based on the life cycle cost. Similarly, naturally, it will be related with the payback period of the plant and also on the internal rate of return. With that, of course, the tariff of the area, prices of components, these are the variables which will be varying. Installation cost, operation and maintenance cost, all these are variables. Because if we calculate today, so after 10 years, these costs will be, the operation maintenance cost might be different. So we have to take into consideration the depreciation and all other things. That is why the internal rate of return comes into picture. Similarly, we have to find the reliability of the plant, that is for how many hours, like load lost, not available. So that also, that in a year for your plant is going to give power for what percentage, or other way of speaking, in other way, for what percentage of time in a year there will be no power. means the plant will not be able to supply power. So that also becomes a very important decision factor. As I said, the life cycle cost, life cycle emissions also nowadays, because we are reducing emissions. As we said, that saw that some country, Norway, is 98, deriving 98% from renewables. Again, now coming to the 100 kilowatt peak solar plant in our installed in our campus. So I'd like to tell you that this plant was installed under the RESCO scheme of the government of India. So we paid the institute, we are an educational institution, we paid not a single pie for the installation of the plant. It was completely free for us, and it was installed in November 2019. So we can say that almost 4 years are going to be complete. Every year we make a report of this plant. So this 100 kilowatt plant for the Gwalior region, based on the availability of solar irradiance here, is generating about 1.30 lakh units per year. Slightly plus minus based on the availability of sun during that year. So this 100 kilowatt plant is generating about 1.28 lakh units per year. And we are exporting, because when the institution is closed, because generally export is not there, because most of the time export is not there, because the solar energy will be during the daytime only, and during the daytime the institute is already working. So we are mostly taking energy from solar plus the grid, because it is a grid connected plant, net metered grid connected plant. So the number of units we produce and we send to the grid, we get paid for that. That becomes positive income for us. And the number of units we take from the grid, for that the grid charges us. In this way, units we are selling also, units we are buying also. And the net result is the tariff is less for us, because some of the power, when the institution is closed, it is Sunday or something, so then we return the power to the grid. All the power generated, no, not much power is consumed here. Even the hostels are closed during the holidays and all. So we found that 378 units only, like 1.30 lakh units we are generating, and only 378 units per year we were able to export to the grid. But during the COVID time, because in 2019 it was installed, so COVID came. So during the COVID times, in the year, for almost 20 and 21, we exported to the grid about between 6,000 to 7,000 units. So we became a generator. MITS, our institution, became a solar generator and contributing to the grid. Then currently the total annual load demand, the total annual demand is about 10.24 lakhs of units. During COVID, it was only 4.35 lakhs. So we can say that about 12%, near about 12% of our institute demand is currently being met, 12%, by the solar plant, the 100 kilowatt plant. Now, Dr. Malvi will tell you that we are all in the process of starting another almost double capacity plant. Exactly, I'm not sure. It is, I think, 250 or 280 kilowatt plant. So you can assume if 100 kilowatt peak is meeting 12% of the demand, so that means by the time we triple the capacity, so it will be about 36 to 40% of our demand, annual demand, will be met by renewables, which will be a good contribution of our institution to the society. And this is also leading to about 10.73 lakhs of annual saving for us. This saving amount comes to 10%, 11%, about 11%. During COVID, the saving was 30%. So at present also about 10 lakhs, or rather 11 lakhs, 11.7, 10.7 is 11. So 11 lakh rupees we are saving due to the solar plant. Our annual bill is getting reduced by 11 lakhs annually. And most importantly, more than money, I will say that this is equivalent to, the solar plant is equivalent to, planting about 5,790, means about, you can say about 6,000 fully grown trees in the campus. Because the carbon sequestration from the campus, from the air, from in and around, because the air is not nobody is a owner of air, air is a universal thing. So our institution is contributing to the society by around about 20 kilograms of carbon dioxide per year. You can say that the solar plant is absorbing. It is not absorbing, but it is not allowing that much of carbon to be dissipated into the atmosphere, and which is equal to about 6,000 trees. So if we had, instead of the plant, if we plant is equal to 6,000 trees, because 6,000 in terms of carbon dioxide emission, or rather stopping carbon dioxide emission. So I think I have already spoken a lot, and there could have been lots of more information. I could have given you a comparative study of the plant, etc. But I think I have already taken more time than was given to me. And some other time we can have a proper delay. And I don't know what has happened to my camera, because yesterday only I was attending a meeting and it was okay. But today I think some setting or some problem is there. So once again with folded hands, because I'm not visible. So I'd like to thank all the speakers and all the experts and all the people from all the executives from the Institution of Engineers. I'm also a fellow member, and I'm very happy that I was able to contribute at least a little through this webinar. And thank you, Dr. Malvi ji, for involving me because
मैम
I'm generally not able to. Because
मैम
of Malvi ji, I could come.
विनय शुक्ला हियर। ये कुछ क्वेश्चंस
Yes.
थे बच्चों के, तो वो थोड़ा सा कुछ आंसर अगर आप दे सकें।
बिल्कुल, हाँ जी, आप बताएं, पूछें आप।
ये लिखा है
बच्चे
कि
पूछें।
हाउ हाई कॉस्ट पावर इलेक्ट्रॉनिक्स कैन बी इंस्टॉल्ड एंड स्टेबिलिटी स्टोरेज रिलायबिलिटी एंड द फ्लेक्सिबल with grid connectivity is assured.
Cost जो है, that is of course a big concern. Cost of the power electronic, the inverter efficiency is generally, you see, if we compare inverter, when we say power electronics, तो solar plant के साथ electronics जो है, that is only the inverter. So when we talk about the inverter and converter also, AC to DC and DC to AC. So both ends, there are converters. So if we talk about it, the inverter is a costly device, and inverter is a costly device, the life cycle of an inverter is about only 5 years. So when we calculate for 12 years, 20 years, sorry, so we have to take the cost 4 times, because inverter will fail after 5 years. So we'll need another inverter. So inverter will not continue. Another thing with inverter is, but inverter is a very high efficiency device. It is a very high efficiency device. So आप कह सकते हैं कि almost 99% के करीब या 98% के करीब the conversion efficiency. So solar power is converted to AC electrical power. DC solar power is converted to AC power with 99% efficiency. So that way it's very efficient. And the inverter costs is also reducing, because power electronics or electronic devices costs are also reducing, but replacement cost we have to consider. That is there. So replacement cost is there, and it is always to be considered when we are calculating the life cycle cost of a solar power plant.
और एक क्वेश्चन और था मैम, ये जो पावर ये चार्जिंग स्टेशंस लगे हैं, लग रहे हैं, तो इनमें अल्टीमेटली स्टोरेज के लिए बैटरी तो रहेगी।
हाँ,
तो
बैटरी ही रहेगी। हाँ
हाँ, और बैटरी की भी एक लाइफ होती है, तो वो जो बैटरियां इतनी सारी निकलेंगी ऑल ओवर कंट्री या ऑल ओवर वर्ल्ड, तो उनकी डंपिंग का कुछ है क्या?
हाँ, ये बहुत अच्छा पॉइंट है, और ये मैं बताना भी चाह रही थी, पर मैं, क्योंकि समय की कमी थी, ये मैं बोलना भी चाह रही थी कि अभी तो हम सब सोलर, वी हैव बीन इंस्टॉलिंग सोलर पावर स्टेशंस एवरीवेयर, but we don't, and they will continue for 20 years, they will keep continue to work. Little bit of degradation will be there in their output. जैसे अभी मैं कह रही हूँ कि we are generating 1.30 lakh units, so they may slightly that may reduce slowly, slightly, but after 20 years what will happen, that is a big concern. So a lot of research is happening, taking place in about the dumping of the solar units. For that matter, why only solar units? All the electronics, whatever we have, the batteries, battery का भी इससे use जो है ना वो बहुत बढ़ गया है. So that is why we are going in a big way towards the hydrogen storage, fuel cells. Instead of this lead acid and all these batteries, we are going towards now fuel cells, which are presently costly, and similarly electric vehicles also. We are going towards electric vehicles, or electric vehicles will also be slowly going to be charged using fuel cells, क्योंकि हाइड्रोजन को सेफ बनाने के लिए काम चल रहा है. एंड अल्टीमेटली हाइड्रोजन सेल में क्या रहेगा कि कुछ वेस्टेज नहीं निकलेगा. एंड एट द सेम टाइम ये भी काम चल, अभी इस समय वो बहुत महंगा है एंड सेफ्टी को लेके कंसिडरेशंस हैं, बट इन वेरी सून वी विल बी हियरिंग अबाउट पूरा स्टोरेज हाइड्रोजन पर ही जाएगा. विल नॉट बी यूजिंग द कन्वेंशनल बैटरीज, ऐसा रिसर्चर्स का एक ओपिनियन है अगर हम पेपर्स में देखते हैं तो स्लोली उस पर जाएगा. और तब तब जो है सिमिलरली जो इलेक्ट्रिक व्हीकल्स हैं उनमें भी जो बैटरीज लगी हैं वही सबसे बड़ा कंसर्न है, तो वो भी हाइड्रोजन बैटरीज यूज होंगी स्लोली. और उससे क्या होगा, इलेक्ट्रिक व्हीकल भी आपको पता है, जैसे यू गो टू ऑफिस एंड यू पार्क योर व्हीकल, होल डे द व्हीकल इज लाइंग देयर. So what you can do is it will be all vehicles will be connected to the grid, and during the time they are parked, they are not being used. So their batteries will be supplying reserve power to the grid. और जब वो बाकी टाइम पे वो अपना जैसे वो डिस्चार्ज हो जाएंगी तो फिर वो ग्रिड से चार्ज होने लगेंगी. सो इवन जो आपका मेरा इलेक्ट्रिक व्हीकल होगा फ्यूचर में, तो वो भी बेसिकली ऐसे ही काम करेगा कि किसी समय वो जनरेटर बन जाएगा. हम मेरी इलेक्ट्रिक कार या मेरी इलेक्ट्रिकल टू व्हीलर जो है वो एक जनरेटर, छोटा सा जनरेटर बन जाएगा. वो पावर जनरेटर, पावर कंज्यूमर भी है और पावर जनरेटर भी. दैट इज द फ्यूचर सिनेरियो.
जॉयदीप जी पूछ रहे हैं कि मैम प्लीज डिस्कस व्हाट इज द अल्टरनेटिव इफ एनीवन हैज नो रूफ टॉप फैसिलिटी.
हाँ, if you don't have rooftop, then there are many other types of solar installations which are being tried nowadays. Nowadays even the window panes जैसे होते हैं, सब जगह ग्लास बहुत यूज होता है बड़ी बड़ी बिल्डिंग्स में, टॉल बिल्डिंग्स में. सो वो उसको ऐसा सुंदर, मतलब दे आर ट्राइंग टू डिजाइन एस्थेटिक टू वर्क एज, मतलब आपकी खिड़कियां या उसकी जगह जो बड़ी बड़ी बिल्डिंग्स हैं तो उनके एलिवेशन में पूरी सोलर पैनल्स आएंगी. और गुजरात में रिवर्स एंड जितनी भी ये नहर वगैरह होती है उनको तो ऑलरेडी कवर करने का काम किया ही जा चुका है. दैट हैज ऑलरेडी बीन डन, दैट दे आर, जो कैनाल्स हैं दे हैव कवर्ड. तो इस तरह से, और अभी हमारे यहीं पर दयालबाग एजुकेशनल इंस्टीट्यूशन है, तो उन लोगों ने एग्रो वोल्टाइक्स पे काम किया है. तो उन्होंने जो जो खेत हैं, खेतों के ऊपर पूरी पैनल्स लगाई हैं. तो उसके नीचे कुछ खास टाइप की फसल होती है जो, जिसके लिए जो शेड में भी उग जाती है और साइड से वैसे भी धूप आती है. तो दयाल बाग ने उसके ऊपर पूरा रिसर्च वर्क किया है. मेरे पास एक पीएचडी थीसिस भी आई थी जिसमें उन्होंने खेतों में पूरे में उसको पार्ट, खेतों पे पार्ट दिए हैं पूरे सोलर पैनल्स. तो क्योंकि इसके लिए एरिया की तो प्रॉब्लम है ही, जैसे हमारे कैंपस में एरिया जगह बिल्कुल भी नहीं है क्योंकि हमें बिल्डिंग्स भी बनानी है अब. तो अभी तो हमारे पास रूफ्स हैं, बट फिर अदर ऑल्टरनेटिव्स जैसे मैंने सजेस्ट किए वो सारे धीरे धीरे यूज होने लगेंगे, हो रहे हैं ऑलरेडी. अगर ये लोग सर्च करेंगे तो बहुत जगह, एयर एयर जो जो आपके एयरपोर्ट्स हैं उनमें सब जगह बहुत सारी जगह खाली होती है, तो वहां पे ये यूज हो रहे हैं. तो सोलर पैनल को बहुत जगह पे लगाया जा रहा है एंड उसको इस तरह से खूबसूरती से डिजाइन किया जा रहा है कि एस्थेटिक्स भी ऐसे गंदे भी ना लगे, वो भद्दे ना लगे.
थैंक यू मैम. खेतान जी कुछ पूछना चाह रहे हैं.
नहीं,
नमस्कार खेतान जी.
आपने जो है ना मंजरी मैडम
जी,
यू हैव गिवन ए वेरी गुड ओवरव्यू ऑफ द सोलर पावर एंड ब्यूटीफुली एक्सप्लेन कि भाई MITS लगा हुआ है
जी
सोलर
सर.
से वो कितना अच्छा है, और आगे आपकी एक्सपेंशन कैपेसिटी 3 टाइम्स करने की है. तो वी वेलकम. और मेरा ख्याल है ग्वालियर में शायद ये पहला ही प्लांट होगा जो इस लार्ज कैपेसिटी का होगा.
जी
तो
सर जी, वो ऑलरेडी हो चुका है सर. वो जो इसकी कैपेसिटी जो है ना, मालवी जी बताएंगे आपको बस वो चालू नहीं हुआ है, पर प्लांट लग चुका है 300 कैपेसिटी वाला। वो
अच्छा
ऑलरेडी
अच्छा
ऊपर लग चुका है, उसको कनेक्ट होना है बस ग्रिड से, और वो थोड़ा सा बचा है।
अच्छा। चलिए, थैंक यू वेरी
थैंक यू
मच।
सर, थैंक यू सर, थैंक यू, थैंक यू सर, थैंक
मालवी,
यू वेरी मच।
थैंक यू मैम। अब मालवी जी अपना प्रेजेंटेशन देंगे।
Namaskar. There's another problem in my system as well. There's a very slow speed as well in my system. So what I'm joined from my mobile and uh, trying to show you my slides from mobile phone. So my slides are visible over here. Yeah. So this a topic was the electronics in the solar panel. So there are, I will try to include the 10 points over differently. Now you can see these are innovation done by the MITS. So MITS has developed 4 different types of the solar lamp, and they have started one startup. There you can check. There are the 4 students sitting over there in a, and they started a one shop, and they built different type of the solar lamp and 40. This is around 4 years back. Okay. And later, they tried to develop a classroom which is solar lighting, which is not only centralized system, but individual system. In individual system, you can check this thing. Like every desk has a lamp, and there's another connection for charging your mobile and the laptop. Now, you can check this thing. This is the classroom, and there's the first part of the classroom over there, and every bench has a different type of the connections, and this type of the lamp and light, and all classroom it is. And they compared this thing as a beautiful project they had done about this thing. Now there's another student who developed this thing for the charging station. At present, we have very less EVs in our institution, so we haven't gone for the charging, but different of the charging station we have practiced and wrote a one project that Yana bicycle over there. So rather than the bicycle, we can go for the charging station bicycle, and a whole Gwalior place can be of this thing. So these are another project. I'm coming back to my focus area to application of the power electronics in this thing. So I will cover only 10 points. So we can be focused for this webinar. This is the application of the electronics in the solar energy. Otherwise, there's a various stories of my PhD and solar installation and different RESCO models, and what questions were being asked from the participant. I will try to answer that thing as well. So for very first thing, solar cells are made of semiconductors. Simply, so the first thing starts with is of electronics. The monocrystalline and polycrystalline silicon cells are widely used in the residential and commercial installation. Companies like Sun Power, LNG, and there are more than 300 companies they are supplying this thing. So these are actually a semiconductor device. This is the first electronics thing. Second is they produce only DC power. The madam already covered this thing, DC to AC inverters. So inverters are the main devices we use for the electronics. Next thing, what happened in morning, we have very less power from the sun, so intensity is less, the current is less. So and in mid time, current is very high and the heat is coming up. So we have to track that maximum power. How we can track this thing? So this is called maximum power tracking device. Again, we have to control this thing. So this is a MPPT system we install over there, and we work very great electronic circuit to get that thing. Next is solar power is not available in the night. So we need to store to get in the night or sun off period. So battery storage system and charge controllers are very specifically designed electronically to get maximum power and high storage. And we everyone heard about the Tesla Powerwall and Tesla Power Calls. Next is micro inverters and string inverters. Somebody will asking for the inverters. What happened in the string inverters? They shared their capacity like 50% each. How to get it? Rather than the micro inverters, they are individually connected with the each strings. So what happened in the string converter? One panel gets failed, the whole power is not coming. While the in micro inverters, every panel is giving a separate power to us. So it's a series and parallel connection. We can understand this thing. In the data monitoring, next point number 6, I should say this thing. In data monitoring system, nowadays, we don't need to go to rooftop to check what is the reading of a meter. So it is simply they display everything, every information. And I should mention this, more than 300 data coming to our mobile phones. Okay, so now whatever requires this thing. So these are data monitoring, and these are IoT based solar system. The one monitor is connected. There's the how DC power, what is temperature, voltage, current of different strings, different panel as well. So everything which is connected, this thing, these are data monitoring is whole dependent on the. Thank you for the electronics and IoT system. They have. Everything is available. We don't need to go in the sun rooftop in very high summer or high winter, or we can check everything on the mobile. These are due to electronics as well. Next point is number 7. Very much is required the protection and the safety. Like this is very important, because like lightning or grid faults, or protecting from the both like PV equipment, connected system from the damage. So we have the different types of the between MCBs, MCCBs, ELCBs, RCCBs. So when we put a lightning conductor, it covers around 50 meter radius to. It means 50 meter radius, so it can be a diameter of the 100 diameter, which can cover if lightning is done. So they can catch. There will be no damage to the roof, solar panel, like was in the building as well. Next is electronic cooling system. Of course, the solar panel converts and uses only visible and ultraviolet spectrum to convert photon to voltage, okay, to the electricity. But on an infrared gives you the heating power as well. So we don't need infrared. However, a bunch of spectrum falling on the solar panel. Now we need this type of the devices, cooling devices, to keep our solar inverters, panel cooling as well there. So that's why we also install. The second reason to install our solar panel on the rooftop bit upper, 1 feet or 2 feet away from the solar roof, because we need a good circulation of the air from natural cooling of this thing. So cooling is required, and devices also required for this one. Now, Madam has already talked about the smart grid, how grid is connected, and what is the solar integration. Madam has beautifully covered for the wind turbine as well, and the connection with the solar grid. So I'm skipping this point. These are very electronic friendly things as well. Now 10 number, somebody will asking for the bifacial solar cell as well. So let me tell you first, the polycrystalline solar cell is like this. Okay, when you find a perfect square system over there, and when you find a pseudo square, this is a monocrystalline, and when you find a thin film, it means a flexible thing. So this is the style how to identify what material is being used for this solar materials and things. Next thing also, this is the monocrystalline is less efficient, and the mono one is the more efficient than the polycrystalline, but less efficiency you will got in the thin film as well. However, there's a very deep mechanical process to manufacture this also, but we don't need to discuss that thing over here. Somebody will asking for the bifacial one. Of course, bifacial is in the trend. But if it's a semiconductor, so you just need a photon to convert then to the voltage. So what happens if you get reflected photons, then also it can be converted. But what happened in the back side of the solar panel is a Tedlar sheet. So we don't need a Tedlar sheet, but we need another glass to give a physical strength to the solar panel. So what happened? The weight has significantly increased of this bifacial solar panel. As weight has increased, you need to put another effort for the transportation of the glass that is covered by this thing. Again, you need a very good installation complexities for the bifacial one. Thus, because it's a double the heavy, and generally 12 kg is required for the 1 kilowatt, then you require 24 kg for the installation that bifacial one. So structural integrity you need to cover this thing. Well, these are solar power aircraft and impulse, and I think these are 6 p.m. Of the time has up. I should stop my presentation, and we can take some questions over there. Coming back to the panel. So I should not go beyond the time limit, whatever assigned to me.
सर एक
Thank you very
क्वेश्चन,
much.
हाँ
Yes, sir.
विनय शुक्ला बोल रहा हूँ। क्वेश्चन
जी
था
सर।
एक, as per latest info, India has now approximate 46% of renewable energy sources as compared to total. But to supply base load demand, we would need fossil fuel or conventional sources. Kindly guide.
Still, we have coal, petroleum, diesel for next 200 years. Still, they are more efficient than this technology. So it is not going to be absolute in next 50, I should say 50 or 60 years. And we targeted this solar installation. We plan for the next 2030 only. So there will be running until we have developed much. After 20 years, we will be in trouble. Like Madam said, we will be in trouble to recycle this solar panel. So there's a both energy need to be balanced, new options to come.
थैंक यू सर। एक और क्वेश्चन था, ये काइंडली इलेबोरेट अबाउट कलेक्टिव सेल्फ कंजम्पशन यूजिंग सोलर, सेल्फ कंजम्पशन।
Collective, I'm not
हाँ।
getting what is the collective one?
यस अरोरा पूछ रहे हैं कि ये कलेक्टिव सेल्फ कंजम्पशन सोलर के द्वारा अपन कितना कर सकते हैं।
Yes, जी, collective. What is collective? I don't know. Solar consumption, it means if we want to connect this thing, so 1 kilowatt required. If he is asking for the space, 1 kilowatt needs a 10 meter square installation space.
ठीक है सर। एक क्वेश्चन था,
मेरा ख्याल है शुक्ला जी कंफ्यूज हैं थोड़ा सा। मैं आपको बताऊं, जैसे सिस्टम की रिक्वायरमेंट 100 किलोवाट है, तो हमको जो ग्रिड से कनेक्शन चाहिएगा वो 100 किलोवाट का ही चाहिएगा। भले ही हम सोलर 40 का लगा लें, 100 का लगा लें, 500 का लगा लें, अगर सरप्लस पावर जनरेट होगी तो चली जाएगी, अदरवाइज वी विल बी इंपोर्टिंग द यूनिट और द पावर। तो सवाल ये है कि कनेक्टेड लोड तो हमारा, या जो मतलब एक रजिस्टर्ड कैपेसिटी है, वो तो उतनी रहेगी जितनी हमारी रिक्वायरमेंट है। सोलर केवल हमको एक एक्स्ट्रा एनर्जी का बूस्ट दे रहा है कि आप सारी एनर्जी ग्रिड से मत लीजिए, हम आपको कुछ एक्स्ट्रा जनरेट करके दे रहे हैं। तो ये मेरा शुक्ला जी को कहना था। थैंक यू।
मतलब ये हो गया कि ग्रिड से कनेक्शन तो रिक्वायर्ड है ही है।
हाँ बिल्कुल
ग्रिड से कनेक्शन है, अभी तो सोलर सिस्टम यही है।
सर उसमें ये भी है कि अगर लाइट चली गई तो आपका जो सोलर लगा हुआ वो भी लाइट चली जाएगी, वो भी बंद हो जाएगी।
चली गई तो सोलर भी जीरो है।
हाँ
यस यस। थैंक यू मालवी जी।
थैंक यू सर।
खेतान सर, अब अपना प्रेजेंटेशन।
बड़ा यूजफुल डेलिब्रेशन रहा, और हमारा ये मतलब ग्वालियर लोकल सेंटर का वेबिनार का पहला एक्सपीरियंस है। दिस इज आवर फर्स्ट एक्सपीरियंस। तो बहुत सारा टाइम तो कनेक्टिविटी और ये सब चीजों में बैठाने में, समझने में लग गया। तो देखेंगे आगे और इससे बेटर क्या कर सकते हैं। तो मैं ऑन बिहाफ ऑफ द इंस्टीट्यूशन ऑफ इंजीनियर्स, मैडम का, मालवी जी का, शुक्ला जी का एवं जितने भी लोग ज्वाइन हुए हैं सबका धन्यवाद करना चाहता हूं, थैंक्स करना चाहता हूं। और पर्टिकुलरली हेडक्वार्टर से जो लोग जुड़े हुए हैं और जो इसको कंट्रोल कर रहे हैं, मॉनिटर कर रहे हैं और रिकॉर्ड कर रहे हैं, उनको भी मैं थैंक्स देना चाहता हूं। सो विद दिस मेरा ख्याल है इस वेबिनार को यहाँ समापन किया जाना चाहिए। थैंक यू वेरी मच।
थैंक यू सर। मैं डॉक्टर सुरेंद्र चौरसिया जी और उनके साथियों का भी स्वागत करता हूं और धन्यवाद करता हूं सारे पार्टिसिपेंट्स।
थैंक यू सर।
मालवी जी आपको बहुत बहुत बधाई। लगभग 70% पार्टिसिपेंट हमारे ज्वाइन हो गए थे इस वेबिनार में, जो हमारा पहला अटेम्प्ट था। तो मेरे ख्याल से अयान देव जी इसको सक्सेस की श्रेणी में डालेंगे।
डेफिनेटली सर, डेफिनेटली।
थैंक यू अयान देव जी, थैंक यू वेरी मच।
थैंक यू सर। थैंक यू।
थैंक यू अयान देव जी, आपका
ठीक है।
प्रयास रहा और हम
जी,
लोगों ने
सर।
कोशिश की।
थैंक यू सर।
आशा करता हूँ कि
Thank you,
आप
sir.
ऐसे ही आपका सहयोग हमें आगे भी मिलता रहेगा
डेफिनेटली सर, डेफिनेट।
और हम आगे इसी तरह के और प्रोग्राम करते रहेंगे। थैंक यू सर।
थैंक यू सर।
ओके,
सर अगर परमिशन मिले तो मैं वेबिनार को एंड करूं यहाँ पे?
बिल्कुल 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 सर।
ओके सर, थैंक यू।
चलिए सर, थैंक यू।
ओके सर, थैंक यू सर।
थैंक
कैतान
यू।
सर, थैंक यू।
थैंक यू।